If you have ever felt physically exhausted after, say, 4 hours of really complex studying, or if you've ever crammed all night just to forget everything a week later,
Right.
you are definitely not alone.
There, yeah.
Most of us, we try to pour a gallon of new information into this tiny 4-ounce mental cup. We're literally wasting our time.
And then we wonder why the files never save.
Yeah.
The biggest scientific insight here is so counterintuitive. You do not wire in new knowledge while you're studying.
Right.
You create the signal, sure, but the actual learning, that happens while you rest.
Welcome to the Deep Dive. Our source material today is this really powerful guide into the brain's rules, and it's titled The 3C Protocol, a science-backed system for rapid learning. And our mission is pretty straightforward. We need to understand the physical and, neurological limits that make traditional marathon studying just fail, and then how we can use a structured system to master new skills faster than ever.
Yeah, we're unpacking 3 essential concepts today that I think will fundamentally change how you approach learning. So first, we have to respect your brain's strict physical limitations. It's a finely tuned machine, not some infinite hard drive.
Okay.
And second, we're going to dive into why productive struggle isn't just recommended, it's an absolutely necessary trigger for creating memory.
And finally, we'll break down the 3-part system itself: compress, compile, and consolidate. This is really the operational roadmap for high-speed mastery.
Okay, so let's start with the machine itself. We often treat the brain like this magical, limitless processor, but the source makes it brutally clear. It is an energy hog.
Right, despite being so small.
Exactly. It's tiny, maybe 3 pounds, but it uses up to 20% of your body's total energy.
Yeah.
That is a massive drain.
So when you're doing something really difficult, like learning to code or reading philosophy,
Yeah, or complex math, you're activating the prefrontal cortex.
which we often call the CEO of the brain, the decision maker.
That's the one. The PFC, it manages your working memory, all your executive functions, but the CEO gets tired, and it gets tired fast.
Yeah.
It runs on glucose and oxygen, and that's a very limited fuel supply.
So when you feel that exhaustion after intense focus, that's a real physical thing.
It is a biological reality telling you to please stop. It's not laziness.
And that leads directly to what the source calls the 4-ounce cup limit. I think that's such a helpful analogy for why cramming is just useless.
It really reframes the whole effort, right? Your working memory, that CEO, it can only actively process about 4 ounces of new complex information at once.
That's it.
So if you try to pour a gallon into it over 5 straight hours, the rest just spills on the floor. It never even gets recorded because you're physically tapped out.
And this is where the computer analogy completely breaks down. Computers use parallel processing. They can do a ton of things at once.
But our brains aren't built that way. We're built for serial processing. We tackle one high-load task at a time. Research shows the brain can only juggle about maybe 3 or 4 independent new ideas before performance just crashes.
So if you add a 5th thing...
The first one often just vanishes. Gone.
So if our biological machine has such rigid physical limits on energy and capacity, what's the single most critical thing we have to change about how we approach learning?
You cannot force your brain to exceed its natural limited capacity for processing new data.
Respecting those limits, that sets the stage perfectly for the next idea, which is also a little counterintuitive.
Yeah.
The power of productive struggle.
Yeah.
Most of us want learning to be frictionless, easy.
I still wrestle with prompt drift myself, leaning too hard on passive input when I know I need active generation. It's just human nature to avoid difficulty, right? We hate feeling stupid when we can't retrieve a name or solve a problem.
But you're saying that exact moment of struggle is the secret weapon?
It is. The source calls it the generation effect.
Okay, so tell us about the science there. Why is straining to remember something more powerful than just, reading the answer again?
It all comes down to active creation versus passive consumption. You remember information much better when you have to actively generate it yourself.
Can you give us a simple example of that?
Sure. Think about a flashcard. Reading the capital of France is Paris. That's passive. Your brain is basically in power-saving mode.
Okay.
Now, compare that to someone asking, what's the capital of France? And you have to pause and strain and search your memory, and finally you retrieve Paris. That little micro-struggle, that's what triggers something really powerful.
That moment of strain is an urgency signal. What's happening chemically in the brain?
It's signaling importance. That difficulty releases neurotransmitters like norepinephrine. It's basically an internal alarm saying, hey, we had to work hard for this piece of info, so it must be important.
It forces the brain to physically rewire that pathway.
Exactly. That's where the real learning happens.
And this is where it gets really interesting with modern AI tools, right? ChatGPT and others are phenomenal, but they can be a huge trap.
A massive trap.
Yeah.
If you use AI to instantly solve a problem or write your essay, you are skipping the necessary struggle. You're skipping the generation effect entirely.
It's like paying someone else to go to the gym for you.
Perfect analogy. They get the workout, you get nothing. You have the answer, sure, but you've missed the neural workout. AI should be a coach that builds the learning environment, not a crutch to skip the work.
So if learning feels easy,
You're probably not doing it right.
so if we rely on AI for that final output, what are we scientifically robbing ourselves of in that moment?
And by skipping the generation effect, we miss the vital neural rewiring that cements new knowledge.
Okay, that brings us right to the action phase. The first C, compress. Since our brain's cup is only 4 ounces, we have to shrink the information itself. How do we do that?
The first technique is selection. It's rooted in the Pareto principle, the 80-20 rule. And this is so liberating because you don't need to learn everything at once. You just need to find the core 20% that gives you 80% of the results.
The examples are so clear on this. Like 20% of chords are in 80% of pop songs.
Or 20% of the vocabulary in a language covers 80% of daily conversation. You have to identify that foundational 20% and just ignore the advanced stuff, at least at first.
And this is a place where AI can be a huge help.
Oh, absolutely. Instead of spending weeks trying to figure out what matters, you can just prompt it. List the 20% of core concepts for Python programming, ranked by importance. That saves you so much time.
Okay, the second compression technique is association, the spider web analogy.
Yeah, it's all about energy efficiency. It is so much easier to catch new information if you can hook it onto neural networks that are already there. You're not building from scratch.
So if you're learning a new history date, connect it to a birthday you already know.
Exactly. You're just adding a new strand to an existing web, which reinforces the whole structure. And the final technique is chunking,
This is pure organization.
turning a mess of data into a simple grouped image, like turning 15 random numbers into 3 phone numbers. Your working memory can handle 3 chunks way more easily.
And the strategy here is to actually draw it out.
Yes. Try to draw the concept. A flowchart, a mind map, something. Force yourself to fit the high-level view on one single piece of paper. If you can't draw it, you haven't compressed it enough yet.
So if we successfully compress the information, what does that look like in a practical, physical sense?
Successful compression means you can sketch a simple, high-level map of the topic on a single page.
Okay, so we've compressed the files. They fit in our 4-ounce cup, but they're just sitting there. How do we make sure they actually work under pressure? This is C2, compile.
Right, this is the big shift from just knowing something to actually doing it. The source material warns us, right? You can read every book about swimming, but if you jump in the pool without practice, you're going to sink.
Compilation is practice. And the first tool respects our biological clocks, Ultradian rhythms.
Yeah, we operate on these 90-minute energy cycles, followed by a necessary dip. So the strategy has to be strict. Set a timer for 90 minutes. Or maybe 45 or 60 if you're a beginner.
Pure, undistracted focus.
And when that timer ends, you stop. You have to stop. Take a 20-minute break.
Pushing past that 90-minute peak is just diminishing returns, right?
Precisely. You're just wasting energy. Then you apply the Agile method to your practice. Don't wait until you feel ready for some big test. You'll never feel ready.
It's about that continuous, immediate feedback loop.
Yes. Learn one small chunk. Test it immediately. Maybe use AI to generate 5 questions. Identify your error and fix only that specific part. This little loop, learn, test, fix, repeat is so much faster than studying for one big exam weeks from now.
So let's talk about the 3 specific tools for this kind of deep practice. First up is the slow burn for physical skills.
This is so important. If you're learning guitar or typing, practice at 20% speed. Moving fast lets you get away with tiny errors, and they become bad habits.
But moving slowly forces you to pay attention to every little detail.
Every single movement. You master it at 20% speed, and then the real speed comes naturally later.
Okay, next is immersion for things like language or soft skills.
You need to have some stakes. You need to get in the arena. If you're learning Spanish, go order food in Spanish. If you're learning public speaking, record yourself. That little bit of pressure wakes up the nervous system and makes the learning stick.
And the final tool, the Feynman technique. This feels like the ultimate test of understanding.
It is the acid test. Pretend you have to explain the concept to a 5-year-old.
And if you start using jargon or getting confusing,
You don't actually understand it yet. You've just exposed your own knowledge gap. So you have to go back, simplify it, and try teaching it again.
Out of those 3 practice tools, which one gives us the most immediate, undeniable feedback on our comprehension gaps?
The Feynman technique instantly highlights exactly where your understanding is weak or incomplete. Mid-roll sponsor read.
All right, segment 5. This is the most critical and honestly the most ignored step. C3, consolidate. This brings us right back to that core truth we started with.
It does. You spend your 90-minute compile block creating a chemical signal. You're flagging files to be saved. But your brain physically saves those files and builds the permanent connections only while you are resting.
So if you skip the rest,
You're basically hitting the delete button on all that hard work.
the source gives 3 really concrete steps here, starting with something almost ridiculously simple. The micro break, just 10 or 20 seconds.
The research on this is just stunning. An NIH study on motor skills, like typing, found that people who took these short 10-second breaks learned faster than people who just powered through.
And the reason why is incredible.
Whoa. This is the hidden power of downtime. In those 10 seconds of stillness, your brain secretly replays the sequence you just practiced at 20 times the normal speed.
20 times faster.
It's called hippocampal ripple activity. It's like getting 20 free, high-speed practice reps without moving a muscle.
So the action step is just close your eyes for 10 to 20 seconds after you finish a small task.
After every solved problem, every page you read, just let the brain catch up. Next up is NSDR, non-sleep deep rest. A lot of people might know this as yoga nidra.
So after a heavy 90-minute session, you take 20 minutes for NSDR. What is that actually doing for our brain?
While you lie down, you're still awake, but your body is completely relaxed. It's a state between waking and sleeping. This slows down your brain waves, encouraging these alpha and theta states.
Which is the perfect state for consolidation.
It's biochemically perfect for transferring working memories into long-term storage. You can find free guided tracks online. Just use one for your 20-minute reset.
And finally, the ultimate save button, sleep. You just cannot hack the need for 7 to 9 hours.
You absolutely cannot. Deep sleep washes away metabolic toxins that build up in your brain, and REM sleep is what permanently wires in the day's learning.
So the math is simple.
Studying for 2 hours with 8 hours of sleep is fundamentally better than studying for 4 hours with only 4 hours of sleep. You have to prioritize the consolidation.
If consolidation is the step we all ignore, what is the single greatest risk of skipping it repeatedly?
Skipping rest effectively presses the delete button on all the hard work you just accomplished.
That's a powerful reason to just step away from the desk.
Yeah.
So let's wrap this all together. How do we use our modern tools correctly here?
Right. AI has to be a coach, not a crutch.
So it's about the prompts.
The right prompts build your learning gem. For compression, you want simplicity. Ask AI to explain something using a simple real-life analogy, and then ask it to break the core idea into just 3 steps.
Forcing it into that 4-ounce cup.
Exactly.
Mm.
For active recall, paste your notes in and ask the AI to generate 5 difficult questions. This is the key. Tell it to wait for your answer before it gives you the solution.
That pause is where the struggle happens.
That's the generation effect. And finally, for planning, ask AI to create a week-by-week study plan that focuses only on the 80-20 concepts and crucially schedules those review and consolidation days for you.
We've covered a ton of ground here, and really, we've fundamentally changed the definition of working hard. Let's just quickly reiterate the 3 C's.
First, compress. Shrink the information down to that vital 20% using selection, association, and then drawing it on one page.
Second, compile. That means structured, immediate practice using stripped Ultradian rhythms, the Agile method, and the Feynman technique.
And third, consolidate. You have to prioritize those 10-second micro breaks, use NSDR for deep rest, and absolutely guarantee 7 to 9 hours of quality sleep.
The ability to engage in this kind of rapid, structured learning, it's arguably the most valuable skill you can have in the 21st century. It's a superpower nobody can take away.
Yeah, you have to stop thinking you lack the gene for learning. You don't. You probably just lack the right process to align your efforts with your own biology.
So think about it. What is the one skill? Photography, coding, cooking, a new language. What's the one thing you've always wanted to master?
Apply this 4-week 3C structure. Start tomorrow.
Yo.
You'll be genuinely surprised at what your brain can achieve when you finally start treating it according to its own rules.